Good morning, students. Today's lesson, Unit 11, Carbon and its compounds. Carbon and its compounds. Today's topic, Homologous Series, Characters of Homologous Series, Nomenclature, Components of Iupac name. First, Homologous Series. Homologous series is a group or a class of organic compounds having same general formula and similar chemical properties, in which the successive members differ by a CH2 group. The first group to second group is only differ by CH2. Homologous series. What is homologous series? Homologous series is a group or a class of organic compounds having same general formula and similar chemical properties, in which the successive members differ by a CH2 group. First compound, methane. The formula is CH4. Second compound, ethane. Formula CH3CH3 or C2H6. The difference between first and the second compound is only CH2. Like the same, second to third compound. The second is ethane. The third one is propane. The difference between second and the third compound is differ by only a CH2 group. Likewise, the third to fourth compound, that is propane to butane, it is also differ by only a CH2 group. Fourth to fifth also only differ by CH2 group. This is the first five compounds. Here, each successive member has only a methylene group more than the precedent members. Precedent means before group. Successive means after the first one to second one. So this is after the CH4. The CH4 is a precedent member of CH3. That is the successive member has only methylene group more than the precedent member of the series, and hence they are called homologues. What is homologues? Each successive member has only methylene group more than the precedent member, that is CH2 of the series, and hence they are called homologues. See the formula, the carbon number is present in the first one, that is 1. Here 1 carbon, 4 hydrogen. This is a methane. Then ethane, 2 carbon, 6 hydrogen, that is C2H6. Then propane, 3 carbon, 8 hydrogen, C3H8. Butane, 4 carbon, C4H10. Pentane, 5 carbon, C5H12. The structure of the methane is, formula is CH4, structure is 1 carbon combined with 4 hydrogen atom with a single bond, that is CH4. Here C2H6, 2 carbon atom combined with 6 hydrogen atom. 1, 2, 3, 4, 5, 6 hydrogen atom. And here 3 carbon atom, 1, 2, 3 is combined with 3 plus 3, 6 and then 2, 8 hydrogen atom. Here C4H10, that is butane. C4, 1, 2, 3, 4, 4 carbon atom combined with 4 plus 4, 8 and then 2, 10 hydrogen atom. Then C5H12, carbon 5 carbon atom combined with 5 plus 5, 10 and then 11, 12 hydrogen atom. This is pentane. This is the increasing order of the alkane group. That is, methane is the first, second one ethane, third one propane, butane, and pentane. The first 10 compounds, first one is CH4 methane, second one is C2H6. So this is increasing order. Here one carbon, here two carbon atoms. Here four hydrogen, here six hydrogen. So the difference between first and the second is one carbon and two hydrogen atom. That is CH2 is differ. See here second C2H6, C3H8. Here one carbon is increased from second to third compound. Here two hydrogen is increased. So different from the second and third is CH2. The third to fourth also differ by CH2. Here one three and H8. See 3 and H8. Three carbon. Here four carbon. Only one carbon is different. Here two hydrogen. CH2 is totally different. Here 4 carbon, C4H10. 4 carbon, here 5 carbon. So 1 carbon is different. And then 10 hydrogen, 12 hydrogen, 2 hydrogen is different. So totally, the total different is from 4th to 5th compound CH2. Now all the one is differ by only CH2 is the different. Okay, first compound is methane, ethane. That is one carbon is present, that is methane. Two carbon, 1 plus 1, 2 carbon. Here 2 carbon, that is ethane. 3 carbon, propane. 4 carbon is present, that is butane. Then 5 carbon, pentane. Pent means 5. 6 carbon, C6 hexane. 7 carbon, heptane. 8 carbon, octane. Then 9 carbon, nonane. And 10 carbon, decane. Okay, this is the first 10 compounds. Then what are the characteristics of homologous series? What are the characteristics of homologous series? Each member of the series differs from the preceding or succeeding member. Preceding means before compound, succeeding means after the compound. Member by one methylene group, that is CH2, and hence by a molecular mass 14 AMU. All members of homologous series contain the same elements and function group. 14 AMU, that is carbon mass is 12, 2 hydrogen mass is 2 ones are 2, so 12 plus 2 totally 14, so it is molecular mass is 14 AMU. So first carbon compound, methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane and decane. Then the next property, they are represented by a general molecular formula. Example, alkanes. General molecular formula of alkane is CnH2n plus 2. This is general molecular formula. The members in each homologous series show a regular gradation in their physical properties. That is regular gradation. That is different from the first to second group, second to third group. Regularly increased their physical properties with the represent to their increase in molecular mass. The chemical properties of the members of a homologous series are similar. This is an important property. The chemical properties of the members of a homologous series are similar. Then all the members can be prepared by a common method. These are also the important properties. First one, they are represented by a general molecular formula. Example, alkanes. Formula is CnH2n plus 2. The members in each homologous series show a regular gradation in their physical properties with respect to their increase in molecular mass. So, chemical properties of the members of a homologous series are similar. All the members can be prepared by a common method only. Why do we need a nomenclature? That is classification. Classification is important. Why do we need a nomenclature? In ancient days, the names of organic compounds were related to the natural things from which they were obtained. For example, the formic acid was initially obtained by distillation of red ants. This is the important point. For example, the formic acid was initially obtained by distillation of red ants. Latin name of the red ant is Formica. So the name of the formic acid was derived from the Latin name of its source. Then the organic compounds were synthesized from sources other than the natural sources. So scientists framed a systematic method of naming of organic compounds. Scientists framed a systematic method for naming the organic compounds based on their structures. A set of rules was formulated by Iupac. The full form of Iupac is I denote international, U union of P pure and applied chemistry. International Union of Pure and Applied Chemistry for the nomenclature of chemical compounds. Components of an IUPAC name. What are the components? The IUPAC name of the any organic compound consists of three parts. What are the three parts? The first part is a root word. Second part is a prefix. Third part is suffix. The components of an IUPAC, International Union of Pure and Applied Chemistry. The IUPAC name of the any organic compound consists of three parts. First one is root word, second one is prefix, third one is suffix. These parts are combined as per the following sequence to get the IUPAC name of the compound. First prefix plus root word plus suffix is equal to IUPAC name, or IUPAC name is equal to prefix plus root word plus suffix. The root word of hydrocarbons. Root word of hydrocarbons. First one, meth. Only one carbon is present. One carbon atom is present. The root word is meth. The start from the name is meth. The two carbon atom is present. The starting word is ETH. If the three carbon atom is present, prop is the root word. Four carbon is present, but is the present root word. Five carbon atom is present, pent is the root word. This is the important one. Then six carbon atom is present, hex is the root word. Seven carbon atom is present, hept is the root word. 8 carbon atom is present, oct is the root word. Then 9 carbon atom is present, non is the root word. Then 10 carbon atom, dec is the root word. Meth, eth, prop, but, pent, hex, hept, oct, non and dec. These are also the root words. The root word, it is a basic unit. What is root word? It is a basic unit which describes the carbon skeleton. How many number of carbon atom is present. So based on this, the root word is described first. It gives the number of carbon atoms present in the parent chain of the compound and the pattern of their arrangement. Based on the number of carbon atom present in the carbon skeleton, most of the names are derived from Greek numerals. What is prefix? The prefix represents the substituents or brands present in the parent chain. The prefix represents the substituents or brands present in the parent chain. This is the prefix word. Atoms are groups of atoms other than hydrogen attached to carbon of the parent chain are called substituents. What is substituents? Atoms or group of atoms other than hydrogen attached to carbon of the parent chain are called substituents. Then substituent F as denote fluoro, prefix word fluoro. Cl, the substituent is Cl, chloro is the prefix word. Then Br is a substituent, bromo is the prefix word. Then I is the substituent, iodo is the prefix word. NH2 is a substituent, amino is the prefix word. If CH3 is a substituent, methyl is the prefix word. That is CH2, CH3. So that is generally C2, that is a 2 carbon atom, and 2 plus 3, 5 hydrogen atom. 2 carbon and 5 hydrogen. C2H5, that is ethyl. Prefix is ethyl. Fluoro, chloro, bromo, iodo, amino, methyl, and ethyl. The suffix forms the end of the name. The suffix forms the end of the name. It is divided into two parts, such as a primary suffix and secondary suffix. What are the suffixes? There are two types. First one is the suffix forms the end of the name. It is divided into two parts, such as a primary suffix and secondary suffix. The functional group and suffix. Class of the compound. If it is the alcohol group, so functional group is OH. Suffix used OL. The word end with OL. Then the class of the compound is aldehyde. The functional group is CHO. The suffix AL is used. Then the class of the compound is ketones. That is CO. Is the functional group, and it is end with, that is the suffix word ONE. Then carboxylic acid, class of the compound is carboxylic acid. The functional group is COOH. That is the word end with OIC acid. That is the suffix word OIC acid. Okay, the class of the compound alcohol. The functional group is OH. The functional group of alcohol is OH. That is the suffix word OL is used. Then the class of the compound is aldehyde. CHO is the functional group. If the class of the compound is aldehyde, the functional group CHO is used. The suffix word AL. Then third one, the class of the compound is ketone. The functional group is CO. That is ONE is the suffix word. Then carboxylic acid. The functional group is COOH. OIC, that is oic acid, is the suffix used. Suffix for IUPAC name. IUPAC means International Union of Pure and Applied Chemistry. These are also the functional group. What are the functional group or examples of functional group? OH. OH, that is alcohol. CHO, aldehyde. CO, ketone. COOH, carboxylic acid. Alcohol, aldehyde, ketones, and carboxylic acid. These are also the functional groups. Thank you, students.